Alright, so we've been talking about transformations the last few days. Today we're going to learn to identify the image of a figure after a combined transformation is performed and then determine whether the final image is similar or congruent to the original. Combined means it might be translated and then reflected, or reflected and then rotated, or rotated and then reflected. It takes two of our transformations and puts them together. So, this could be a long lesson, I don't know. I guess we'll wait and see what happens. Identify the combined transformations from the original to the final image and tell whether the two figures are similar or congruent. So, the original is the one with no commas. The first transformation is the image with 1 comma. And the final transformation is the image with 2 commas. Okay? Or double prime. So, we want to look at the original. Okay, we're looking at these two here. So we're first going to look at the original to the first image. Okay, so we're going to have our coordinate points of A, which is 1, 1. Our coordinate points of B, which is 2, -1. Right? Yeah. Our coordinate points of C, which is 3, -5. And our coordinate points of D, which is 2, -5. And it might be helpful to along here, right? A, B, C, D. So you remember which is which. Okay. Now we're going to look at the coordinates of A prime, B prime, C prime, and D prime. Okay? So A prime is 1, 1. B prime is 2, 1. C prime is 3, 5. And D prime is 2, 5. And this would help if I had my coordinate of A right. Remember this A right here? That's a -1. So A, the original A is 1, -1. I had 1, 1 down. I'm sorry about that. So the y coordinates, if you compare them between the original and the primes, are opposites. Meaning if they were originally positive, they went to negative, and if they were originally negative, they went to positives. So the x, y is x and negative y because we multiplied each y value by a negative in order to get the new y value. So this is a reflection across the y or x axis. Man, my mouth is not working. The words coming out of my mouth. Okay, so now we are going to look at our first image compared to our second image. Okay, so we are going to erase that, have A prime, B prime, C prime, and D prime. Okay, so A prime is 1, 1, which we already know from above, so we can just copy those down. B is 2, 1. C prime is 3, 5. And D prime is 2, 5. And I got those from here real quick because we're looking at the same image. Okay, now I'm going to my third image, which has the 2 little commas after. So, my coordinate for a double prime is -3, -2. B double prime is -2, -2. C double prime is -1, 2. And D double prime is -2, 2. Okay. So if you notice on these, the x's, if you compare the x's of our image and our second image, they all went down, they all decreased, and they all decreased by 4. If you subtract 4 from all your x's here, you would get all these x's. And the y's, if you compare them to get from these y's to these y's, you have to decrease them by 3. Okay? So, our x coordinate was decreased by 4, which means subtract. So we have x minus 4, and our y coordinate was decreased by 3, which again means subtract. So we have y minus 3. Okay, so this is a translation because we just added or subtracted to our x and our y. So, each transformation is a congruence transformation. Therefore, the combined transformation is a congruence transformation. And you know they're a congruence transformation because if you were to take these coordinates and graph them, you would get this picture here. And if you were to take these coordinates and graph them, you would get this picture here. You don't have to add all those circles. Identify the combined transformation from the original to the final image and tell whether the two figures are similar or congruent. So, we are going to be looking at these transformations, and it tells us how to look at them. It says we're going from this to this. Okay? So, they messed up. This should be A, B, C, D, and this should be A prime, B prime, C prime, D prime. Alright? So they messed that up, so hopefully you fix that. So, coordinate of A is 1, 0. B is 3, 1. C is 4, negative 1. And D is 2, negative 2. Alright, so we took our original because this was wrong. It's supposed to be our original. And then we're going to our first image. So that is wrong. In our first image, A prime is at negative 1, 0. B prime is at negative 3, negative 1. Oops. C prime is at negative 4, 1. And D prime is at negative 2, positive 2. Okay. Both of the coordinates are opposites, right? On each of those, the signs in front of the coordinates switch to their opposite. So the rule is negative x, negative y. Both switch their opposites because we both multiplied them both by negative 1. So this is a 180-degree rotation. So 180-degree rotation, you multiply both by negative 1. Now, we are going to go from our first image to our second image, okay? And we get our first image coordinates from right here, so we don't even have to think about it. So, negative 1, 0, negative 3, negative 1, negative 4, positive 1, sorry, and negative 2, 2. And now we got to look at our second image, or the image with 2 little commas. Okay? So when we do that, A double prime is, it's really hard to see, negative 0.5, 0. B double prime is negative 1.5, negative 0.5. so negative 0.5. C double prime is negative 4. Just kidding, I messed that up. Is negative 2, 0.5, and D double prime is negative 1, 1. That was hard to see with that little teeny tiny picture. Okay, both of the coordinates are multiplied by 0.5. Okay? On all of them, we took half. Negative 1 divided by half is negative half. Okay? So, that means our rule is 0.5x, 0.5y, because we multiplied each of them by 1/2. This is a dilation, because if you notice, not all of those are the same size, okay, with a scale factor of 0.5. So, one transformation is a similarity transformation because it grows. So, the combined transformation is a similarity transformation. So remember, it's a congruence transformation if they're the same size. It's a similarity transformation if it gets smaller or bigger. Find a sequence of at least 2 combined transformations for transforming the original to the final image. Justify your answer. So, the original and the final image appear to be congruent. They appear to be the same size and shape. So the sequence of transformations may consist of congruence transformations. Alright, so we're going to reflect it across the x-axis, and when we do that, remember the rule is to multiply the y by negative 1. Okay? So, in our original ABC, our coordinate points are negative 5, 1, B is negative 2, 4, and C is negative 1, 1. Okay? Now, when we multiply by negative 1 for our y, we get, negative 5, negative 1, negative 2, negative 4, and negative 1, negative 1. Okay? So what we're going to go do, is we're going to graph that. There. To negative 4 is there. And negative 1 is there. Okay? So now we have this here. And this is my A prime. This is my B prime. And this is my C prime. Okay? Now we're saying we took that purple triangle and we did a 90-degree counterclockwise rotation about the origin. When we do a 90 degrees counterclockwise, we multiply the y by negative 1 and then we flip our x and y coordinates. So, we're going to take our A prime, B prime, and C prime coordinates, which are all right here. So we're going to have negative 5, negative 1, negative 2, negative 4, and negative 1, negative 1. Okay? And then we're going to get our A prime, B double prime, and C double prime coordinates. And we get those simply by flipping our prime coordinates and flipping the y to its opposite. So, our y right now is -1, so it's going to be 1, and we put that in first position, followed by our x. B prime, our -4 is negative, so we switch it to its opposite, which is 4, put it in our x position, and then -2, because we switch the coordinates. And then C, our -1, the opposite of -1 is +1, and we flip them. Okay, so there you go. These will all be those coordinates, or should if you did the work right. So identify the combined transformations from the original to the final image and tell whether the two figures are similar or congruent. Remember, similar means they were dilated in some way. Congruent means they're the same size. Honestly, it doesn't really matter about the points. I don't know where I got that from. So throw that out of your brain and just remember that similar is if it's dilated or either bigger or smaller, and congruent is if it appears to be congruent.